by these tracts. All right. Now let's see what happens again and again and again. I'm very repetitious in anatomy in general, and I'm very repetitious in neuroanatomy. If we repeat, things become a lot easier. So the general idea of ascending tracts is that you're getting a sensation from your hand, let's say. You get it all the way to the, you get it all the way by the first order neuron, getting this sensation. The cell body is in the dorsal root ganglion, and then you're gonna stop at somehow in the nuclei of the posterior gray horn, and then it depends on what kind of tract is it. You're going to decussate or known at that level, and then you go up by second order neuron, and then you stop at the thalamus, VPL, and then you send the third order neuron. Now, let's start with pain and temperature and what happens to it. Guys, I'm not gonna read, and I did this because I want to help you to have everything written, but I'm not here to read this. I made it only for you, and I just want to explain that to you. Okay, so let's get back to this slide. I will explain to you the spinothalamic tract, and then we will come to the tract of Lissauer. Hold on. I think tract of Lissauer slide will help, or Lissauer. Yeah, this one is good. Okay, so what happens in the pain and temperature, or let's say even light touch and pressure? You guys, what happens? Now you are having a pain or temperature. You are receiving a sensation. The sensation is coming from the first order neuron to that level, okay? And then it's going to ascend or descend. Now let's talk about, let me see what happens here. Yeah, let's talk about this. I love this diagram. We have here a spinal cord level at T2, all right? So I have a sensation that is coming from my chest region. The sensation is carried by first order neuron here. It comes all the way through the dorsal horn, of course. This is the sensory root, right? This is a sensory root. And this is the H-shaped horn, okay? Now, once it comes here, it will ascend up for 1 or 2 levels maximum, okay? And then it will stop in one of the gray horn nuclei, okay? It can also descend down. Why? Because we want to keep track of what's happening in the upper and lower segments. The posterolateral tract of Lissauer or Lissauer is basically, once you have the pain, temperature, and light touch and pressure, once you have this sensation, you need to ascend, and then only you can decussate to the other side by the anterior commissure and ascend as lateral spinothalamic tract or anterior. Now, why is it important? Because you guys, okay, let me tell you why is it important when we talk about the lesions, okay? So what happens is once you get the sensation, you go up in the in very near to the sensory horn. You stop at the substantia gelatinosa of Rolando, okay? You stop at this nuclei. This is all first order neuron. And from there, you will give the information, you will give your message to your friend at the substantia gelatinosa, okay? This is gonna send the cell body of the second order neuron is sitting in the substantia gelatinosa of the posterior horn of spinal cord. And then you will decussate in the anterior horn cells. Anterior horn cells what? In the anterior commissure. Commissure means something that connects right to left. So you go all the way, and then where do you go? You go to the white matter, because you have a very long distance and you cannot go by gray matter. Gray matter is just, you guys, for the cell bodies and for the small neurons. It's not for a tract that is going up and down. So once you are a lateral spinothalamic tract, it means you are here in the lateral column of the spinal cord, okay? And then, so the first order neuron comes to the sensory horn or posterior horn. It enters through the sensory root. It ascends 1 or 2 levels, forming what we call the tract of Lissauer. This is important for the reflexes, and it's important to be aware of up and down sensations. And it's also important in lesions, and we're going to talk about that in the coming videos. Here, You finish the information. This sensory, the first order neuron, done with the information about pain and temperature. Now you will give the message to the second order neuron in the substantia gelatinosa. Here are the group of cell bodies of the second order neuron. They are ready to take the message to the third order neuron people. So we will cross. Once we get the message, we need to cross. We will cross now and ascend to the VPL of thalamus. We give it to the last people. Thalamus, guys, is just a group of nuclei. Cell bodies. Nuclei means cell bodies in central nervous system. This is my neuron. This is my neuron. If I have cell body, this is cell body. This is the cell that carries the information, neuronal information. So if I have a group of nuclei, it means I have a group of cell bodies. Okay, cell bodies are sitting here and they are waiting for the information, and based on that, they will decide where to go. And once you have the third order neuron, they took the information, they will take it through the posterior limb of internal capsule to the somatosensory area. Okay, so this is what happens in the spinothalamic tract. You have first order neuron sensation, you've ascended up, you relayed in the substantia gelatinosa of the posterior horn, you give the information to the second order neuron, you cross to the other side, you ascended in the white matter all the way up to the thalamus. You give the information to the third group of people, which are the third order neuron, the ventral posterolateral nucleus of thalamus, and then through the, we're going to talk about, you guys, the internal capsule in details as we reach the cerebrum, okay? So just know it for now. From there, you will reach the somatosensory area. You will get into the brain center that knows the sensation, and you will feel that this is something hot, and I need to wait for that for some time so that I don't burn myself. Okay, so this is an example of a sensation. Okay, so what happens in the posterior white column? Posterior white column, it's the same idea. We have sensation, but that is proprioceptive sensation, and we already talked about that sensation. It could be a very fine touch also. So fine touch is carried by the posterior column. So you get the information through the first order neuron. You enter by the dorsal sensory route. Once you enter posteriorly, you have to switch yourself into the posterior column. Why do we do that? We do that because as a tract, I need to move in the white matter because by definition, white matter is the myelinated axons. It's important because it speeds up the information. So I need to switch to my tract so that I can travel a long distance. Once I travel a long distance by the posterior white columns, I go all the way to my first stop and the place for the second order neurons. What is it? We have two nuclei in the medulla. We call them nucleus cuneatus and nucleus gracilis. Gracilis and cuneatus. Gracilis and cuneatus. What's the difference between them? Gracilis is more, if this is what? Okay. So even spinal cord or medulla is nothing but continuation of the spinal cord. The gracilis, you guys, is medial and the cuneatus is lateral. The gracilis responsible for lower limb information. Remember that by the graceful legs. Okay, graceful legs, information from T6 and below. If you have information above T6, it means you are in the cuneatus, outside. Okay, so once you get the information, sensation, and you're moving in the posterior column, if you are bringing information from lower limbs, it means you're gonna be medial. If you are bringing information above T6, you are lateral. You're ascending in the posterior column. Once you reach the medulla at the level of these nuclei, remember, nuclei are group of cell bodies of the next group of people that are going to take the information to the next. It's not a term, it's not something that we need to memorize. It's something that we need to understand. It's a nucleus and it has a name. Gracilis, cuneatus. They are there in the medulla, and we're going to talk about that in the medulla video in more details. So now you have to stop there. And if you are bringing information from the lower limbs, you have to stop at the level of the nucleus gracilis here medially, and the cuneatus is lateral, and you give your information to the next group of people. Once you are giving the information to the next group of people, you need to decussate. You will decussate to the other side at the medulla, and you're gonna ascend as medial lemniscus. Why it's not a tract? Because tract is a terminology, we use it in the spinal cord. Here we are at the medulla. We're going to the pons, midbrain, and thalamus. We are in the brain stem. In the brain stem, we don't understand something called tract. We should give it another name that we understand. What we understand here is something called lemniscus. Lemniscus is the same tracts grouped together in a very small space, and they know where they are going. If they are bringing information about proprioception, we call it medial lemniscus. If they are bringing information about sensation, pain and temperature previously, we call it spinal lemniscus, and we're going to talk about that next week. And when I upload them next week, I mean, of course, for the upcoming years, we're going to talk about that in the brainstem videos, okay? So it's just another name. Once we give the information to them, we call them medial lemniscus, and then we ascend up, and then we stop at the thalamus, at the ventral posterolateral nucleus of thalamus. All the sensations coming from the spinal cord, once they reach the thalamus, they will go to the PVPL of thalamus. And from there, you're going to give the information to the last group of people, the third order neuron, to the somatosensory area in the cortex, and you can feel that sensation. Okay? All right, what happens to the spinocerebellar tracts? In the spinocerebellar, we're gonna stop at the cerebellum. Okay, if we stop at the cerebellum, then how will I control the movement? You guys, when you reach the cerebellum, you will know why you need to stop at the cerebellum, because the cerebellum does not work on its own. It's going to have communications with the big boss, of course. It's going to have communications with the brainstem nuclei, and the big boss will have communication with the other brain regions, and everything is nicely connected. So don't worry and say why all of them they go to the cortex and this one goes to the cerebellum. When you reach the cerebellum, you will understand how beautiful this system is. Okay, so as for now, you have information, you have the spinocerebellar, the sensation comes in the spinal cord from the posterior horn, it will ascend. Okay, it will have to stop at the nucleus. We call it Clark's nucleus or nucleus dorsalis. It's also in the dorsal horn, and I have a nice table for you. So if you want to memorize the names of these nuclei, because if you stop at the spinal cord level, you have to have the name of this group of people who are going to take your information to the next group. We call them nuclei. In the spinal cord, in the posterior horn, which is responsible for sensation, for the spinocerebellar, we call it Clark's nucleus. Once you have the information, you're going to ascend. The cerebellum is controlling the same side of the body. The majority of these tracts, they will cross and recross. No, I think the majority will not cross. Most of them, they don't cross. And the small amount of them who cross will recross. I think, I think this is 15% and this is 85%. Anyway, the spinocerebellar tracts, we have posterior and we have anterior. Okay, spinocerebellar. The posterior one will go all the way and they're gonna enter the cerebellum from the inferior cerebellar peduncle. We're gonna talk about everything related to the cerebellum in their videos. Just you need to know now that this information goes to the cerebellum here, okay? And if I have the anterior tracts, they're gonna cross and then enter the cerebellum, exit again, recross, and go to the same side. So the take-home message here is cerebellum controls the same side. Cerebellum controls the same side of the body, okay? And we already know what does the cerebellum do. The cuniocerebellum, it's just the same idea. We take some of the information coming to the cuneate nuclei, and we give it to the cerebellum. So we call it cuneo-cerebellum. Okay, so we have sensory information. Once they reach the cuneate nucleus, the same nucleus, you guys, that we talked about it previously in the proprioception, remember? So some information from that, we will take it to the cerebellum so that we can know unconsciously what proprioceptive sensation is happening and how we can control them. Okay? All right, so what happens here, once you reach the cortex, you have a somatotropic organization. I'm not going to get into the details of this because that will be explained in the cerebral cortex, okay? Now, as a summary, I made you a beautiful tables after explaining the whole pathway for the ascending tracts. We're going to go through them one more time together. I made so many learning tools. I hope one of them you can find it interesting for you and help you to grasp the concept. And hopefully by the end of this, neuroanatomy will be a piece of cake, and especially the ascending tracts as for now. Okay, so we already talked about the spinothalamic tract. We already talked about the dorsal columns or posterior white columns. The same name, by the way, guys. Dorsal columns are the same posterior white columns, and the spinocerebellar. Talked about the function of them, and we talked about where do we stop. At the beginning, you have to stop at the sensory horn. Okay, the motor neurons, we will talk about them in the descending tracts. So here we have a group of neurons, cell bodies, neuron cell bodies. Here you have to stop if you are having spinothalamic tract, pain temperature, light touch pressure. You have to stop at the substantia gelatinosa of Rolando. If you have information about spinocerebellar, spinocerebellar here, dorsal, sorry. If you have information from spinocerebellar, like I said here, in the dorsal nucleus or nucleus dorsalis or Clark's, the dorsal nucleus, it's here. Okay, so if you look at this, the nucleus dorsalis, this is the spinocerebellar. And nucleus proprius is going to be for the dorsal columns. You have to stop here and ascend. Okay, so like we took them in order. If that was our spinal cord, we had this dorsal root ganglion for the sensation. The cell bodies were here. If we enter and stop here and send second order neurons, and then we decussate, this is spinothalamic tract. If we are bringing information, let me make it here. If we are bringing information about proprioception and we are stopping here without decussating and ascending up and decussating in the medulla, this is the dorsal columns, because dorsal columns, they don't decussate here. We have them ascending at that point, and this is the nucleus proprius. And I don't know if you need to know it, if it's in your teaching material or no, but this is just general information for everyone who need it. And then you will ascend in the dorsal columns, and there you will going to stop at the cuneate and gracilis nuclei of medulla, and from there you will decussate and send the second order neurons to the thalamus, and from the thalamus, third order neuron to the cortex. All right, and the last thing is the spinocerebellar tracts. They will enter, they will have to stop at the nucleus dorsalis, and then they need to ascend without decussating and without crossing. And if they were cross, which is few amount of the these anterior, which we call them the anterior spinocerebellar tracts, they will cross back and get to the same side of cerebellum. So all of the cerebellar problems are ipsilateral. If I have a patient with a right cerebellar stroke, he will have problems in the right side of his body. Okay, he will have tremors, problems, hemiplegismus, and all of the cerebellar problems in the same side of the body. Okay, so these are all summaries for you guys. The spinothalamic tracts. I just want you guys here to grasp the concept that we are just giving other names. So it's a whole pathway, but the same spinothalamic tract, when it reaches the brainstem, we call it spinal lemniscus. The dorsal columns or the posterior white columns, once we reach the tegmentum of the brainstem, we call them medial lemniscus. Okay, but we have more than two lemnisci. They are originating from the head and neck, not by the body, and we will come to know them, which are the trigeminal and mesencephalic lemnisci. We will talk about them, inshallah, once we reach the brainstem. But as for the spinal cord, this is just another names of our tracts as we reach the brainstem. It's a whole journey, guys. You just need to memorize the names of them, just the names. And once you understand what do they do, everything is going to be easy. And these are all summaries to help you that these tracts with these functions, the third stop for them is the thalamic nucleus. This is the thalamus. And like I said to you guys previously, the thalamus is nothing but a nice structure. It works as a relay station. It's like a secretary for the brain. Based on the sensation, you will know where to stop. Our target in this spinal cord is the VPL nucleus of thalamus, and every one of the other nuclei will be responsible for different things, and we're gonna talk about that in the thalamus video. You just need to know this group of nuclei that will give you the third order neurons from here to reach the cortex. Okay, so here we are at that level of our pathway. Okay, so I already put for you all of the pathway along with the summary I have, so that I want to make sure everyone has a very nice image in his brain when he's studying this all the time, because that will make the information so much easy. Like we said previously, once the tract gets out of the thalamus, it's gonna be going through the posterior limb of the internal capsule. We're gonna talk about the internal capsule. We're gonna talk about its limbs, everything we're gonna talk about in details once we reach to them. You just need to know that this is a part of your pathway if you want to reach your somatosensory area. And after all, we've reached the final destination. The sensations are there in the somatosensory area. We can feel them. We can appreciate how nice and great blessing is it to feel a sensation of everything happening around us. And this is just was supposed to be a recap. I don't need to get into this detail, and we will talk about the legions, and we will get into that soon. Here is a very nice somatotopic organization cross section to tell you guys that as for now, we've already talked about this half, because this half is wait, this half is the ascending tracts. All right. So for the posterior column, you need to know that the medial part is for the lower limbs, what we call the gracile, the graceful legs, T6 and below information. And laterally, you have the cuneate. And once, طبعا, they wrote it as such because they were reached to the gracile nucleus of the brainstem and the cuneate nucleus of the brainstem, or medulla to be specific. Okay, and this is medial to lateral. And for the lateral spinal thalamic tract, you need to guys to know that medial is up is medial. Okay, it's always like that. Exclude the posterior columns from our talk now, but everything medial, everything up. Okay, everything medial to us. Okay, we make him up. We make him a priority, right? So remember that the cervical region, thoracic, lumbar, and sacral. Cervical is up, it's most medial. So if there is a problem here, it's going to affect the upper regions first. The same applies for the descending tract, the corticospinal, and we're going to talk about that in details in the legions of the spinal cord. Thank you guys for watching. I enjoyed actually teaching you this video, and see you in the next months. And I hope you grasped all the concepts of this video. See you next.